Hello everyone, my name is Nitin Goyal. Today, me and my friend Priyanshu Maurya would be discussing this applied instrumentation experiment, which is speed measurement using electromagnetic transducer. This video is divided into three parts. First, we will discuss about the apparatus of the experiment. We will discuss about the theory behind this experiment, and we will discuss the procedure, like how to perform this experiment. So let's first start with the apparatus part. So the apparatus is like this, as you can see on your screen. This is the electric motor, and to the electric motor is attached a disc which is containing 15 slots, and there is this electromagnetic transducer which would detect the motion of the disc when it is being rotated, and the output of this transducer would go to this speed measurement training kit, which would pre-process the output before projecting it onto the oscillometer, as you can see there. So this is the oscilloscope which would display the output of the which would be coming from the electromagnetic transducer. So this is the multimeter which would be displaying the voltage which is being applied to the DC motor. So that's it about the apparatus. Now we will discuss about the theory behind this electromagnetic transducer.
Hi, my name is Priyanshu Maurya and I am with my teammate Nitin. I am going to explain this transducer and electric motor part. So here we can see there is a shaft, and this is electric motor, and this is the electromagnetic transducer. And this shaft has 15 slits. And what you can see, every time this slit passes, there is a light blinking. This is because the transducer has an electromagnet, and every time this iron passes through front of it, there is a change in flux that causes the change in current, and that's why there is a blinking of light. And this output is gone through the trainer kit, and from here we have a wave shaper, because when the flux passes, it doesn't create a proper wave. So wave shaper, what it do, it changes it into rectangular wave. And then we have a multiplier. This is a multiplier of 4. This is because we have a 15 slit, and 15 into 4 is 60. That makes the calculation part convenient for measuring the speed. And then it goes through a counter, and here we have the speed counter.
So now I will explain how to perform this experiment. So as you can see here, the motor is stationary. So we have to rotate this knob to get the motor started. So now you can see I have increased the DC voltage and the motor has started to increase. You can see the multimeter also, the reading has increased there. And on the oscilloscope you can see there's a proper rectangular waveform with frequency 250 Hertz. Now as you can see in the trainer kit, the output is from the wave shaper directly. Now if I put it to this multiplier slot, now you can see the frequency is almost multiplied by 4, and here you can see this switch is to the RPM, and the RPM reading is shown in this digital meter also. So this was all about how to take the RPM. Just also we have to take more readings, so increase this power supply, the motor speed will increase, and the frequency will increase, and also the RPM would increase. Yeah, that's it about RPM. Now Priyanshu Maurya will explain how to calculate how to measure the speed.
Now I am going to explain the part how to calculate the speed, and that is basically the linear speed we calculate. So first we shift RPM from RPM to speed, and then reset. Now when we push to count, it start counting the number of slits passes through it. So we set a stopwatch of 10 seconds and then push to count, and after 10 seconds we just stop it like this, and we note this. This is the number of slit passes through the transducer in the 10 seconds. So from here we do some calculation and get the linear speed accordingly.
So that was all about the experiment. Now we would like to discuss some precautions and other points about the experiment. So the first precaution would be the material which we are using here, which is the disc part. The disc part should be a ferromagnetic material, because the whole basic idea of the experiment is based on a Lenz's law. So if the magnet is not ferromagnetic material, there would be no disruption in the flux lines. So obviously there would not be detection of any flux change.
And make sure the oscilloscope variables are very tuned fine. Otherwise you will not able to see the wave part. And the wire should be proper tight, so that there will no possible case of noise in the oscilloscope. And make sure you count the time well and do it precisely.